Okay, here we go. I feel like this section is gung-ho trapezoids and then a little bit about kites, but kites have amazing properties in them. So trapezoids, we're going to focus on those ones first. Here we go. Trapezoid, the most basic definition is it's a quadrilateral, has to have 4 sides, that's what quadrilateral stands for, and then it has one pair of parallel sides. Just one. So trapezoid is not a parallelogram because both pairs aren't parallel, just one pair. So if you want to add a sketch to your notes, I highly suggest it. This could be a trapezoid, but then don't forget you have to have one pair. It's parallel. Okay, next vocab word is about bases. The bases are just the parallel sides. So this side right here is called a base. And then this side right here is also called a base. Hopefully you've already seen this because when you were in algebra, pre-algebra, you had to find the area of a trapezoid, and the area formula involves both the bases. You have to add them together. Okay, there's 2 pairs of base angles. That actually comes up more in a certain type of trapezoid. So I'm just going to call this a BA. This one is a base angle, and this one is a base angle. This is one pair. They both share this base. And then above it, this is another pair of base angles. They have to share the same base to be a pair of base angles. Okay, and then the last thing, if you ever see the vocab word legs, when it comes to trapezoids, it's those sides that are not parallel. So this is a leg, and this is a leg. That's it. Just gotta remember. Okay, for the next part, again, we're on page 131. For the next part, isn't it isosceles trapezoid? Because do you remember what isosceles stands for? 2 congruent sides. So you have congruent legs. The legs are congruent, not the parallel sides. The legs are congruent. And then the mid-segment, that might not make sense to you, that definition. We'll draw a picture, and I hope that that turns the light bulb on. The mid-segment, you connect the midpoints of the legs. We'll draw it. First, let's draw an isosceles trapezoid. We've got a parallel side and a parallel side. Do my best. Don't forget your parallel symbols. Make sure it's a trapezoid. Check, check. But then it's saying this is congruent to this. That's an isosceles trapezoid when those legs are congruent. Okay, this comes up later in the notes, but I'm going to show you right now. Because if this leg is congruent to this leg, something's going to happen to this base angle and this base angle. Any guesses? Look at them. They kind of look. This one, what kind of angle is it? Right? Acute, obtuse. This one's acute. This one's. They're both acute. They're also both. Oh, I heard it. Yeah, they're the same. They'll be congruent, but only in isosceles triangles. This base angle will equal this base angle. Okay, well then what do you think about the top base angles? Think the same thing will happen? They're congruent, but make sure they're congruent to each other. So this base angle will be congruent to this base angle. Okay, let's draw another picture for mid-segment. So draw yourself another isosceles trapezoid. However, I'm just going to put on the parallel sides. I'm not going to do this is congruent to this. Just remember, we're doing our best to try to get an isosceles trapezoid. Because I'm going to draw over those legs. To find the mid-segment, middle, find the middle of a leg. We'll just eyeball it. We won't bust out the rulers. Maybe halfway like right there. Maybe halfway like right there. That's the midpoint of both sides. The mid-segment is just the connection of those two. Midpoint to midpoint. Right here, this is the mid-segment. Now there's a property about mid-segments that again we'll get into later in your notes, and it's kind of similar to something we did with triangles. I think you'll probably pick it up fast. Okay, do we just have one little spot for our kite? Because that whole page took over trapezoids. Here comes the kite. There's a few things about it. We talked about it a couple days ago. Okay, kite has to be quadrilateral, so it has to have 4 sides. The kicker on the kite is this keyword, consecutive. Consecutive sides are congruent. The opposite sides are not. So is a kite a parallelogram? No. Is a trapezoid a parallelogram? No. So they don't have parallelogram properties. Okay, so I don't know if you remember a few days ago we did this. Consecutive sides are congruent. So this is congruent to this. Stretch this one out. This one's congruent to this. Literally looks like a kite. Okay, I think you want to give 2 things away. Again, it comes up later in the notes. First off, have any of you flown a kite lately? I think it's been like 10 years for me. It's been a while. I don't know if you remember, but when you hold the back of a kite and then you throw it up in the air and someone goes running or the wind catches it, do you know what shape is on the back of every kite? Yes, it's a T. Guess what? Those are the diagonals. It's built that way on purpose. What color shell? Let's use this one. So on the back of the kite, we've got this and this. Well, a T in geometry, what does that mean? They're perpendicular. Diagonals will be perpendicular. What else do I want to give away? Okay, it's a quadrilateral, so all 4 of these angles add up to equal 360. That's any 4-sided shape. But in kites, something's going to happen with only one pair of opposite angles. Only these 2 will be equal to each other. Do they kind of look like they would be equal? And then do you think this one equals that one? One pair of congruent angles, opposite angles. I think that's all I want to give away right now. Let's see what's next. Flip the page. Okay, this is stuff we've gone over. Now remember, it's only true in isosceles trapezoids. So if you can, please circle isosceles. If it's isosceles, then the base angles are congruent. Go over to your picture and draw the base angles. This would be congruent to this. That pair of base angles. This is congruent to this. That pair of base angles, but only in isosceles. The next theorem is the same thing, only backwards. You see a picture, you notice one pair of opposite sides is parallel, and then you notice one pair of base angles congruent, then it has to be an isosceles trapezoid. It's like backwards. If you had to name the shape, you'd say isosceles trapezoid. Okay, last one. Same thing as before. Circle this. It must be isosceles. If it's isosceles, then the diagonals are congruent. So that's a new thing that could come up on a quiz. So many things about each shape, right? Okay, we're in the middle of that next. The same page. This one, you've got it. Try it out. Figure out all 4 angles if it's keyword isosceles. Here we go. Be confident. Angle X, what does it equal? 110. Perfect. Angle Y, what does it equal? 70. Nice. And then this one has to be 70. Okay, I heard some of you notice this. What's the relationship in an isosceles triangle with these 2? Yeah, so if that's easy for you to figure out, go for it. Otherwise, you can subtract from 360 and go from there. Go work. How many of you? I got that. Perfect. Okay. This one. Okay. Deep breath. This is kind of like our assignment where we had to find the slope and the distance formula. However, on this one, it just says trapezoid, right? Does it say anything about isosceles trapezoid? It's actually really nice for us because the only definition for a trapezoid is that one pair of opposite sides is parallel. So that's all we have to show. It's already a 4-sided shape, so it's a quadrilateral. So on this picture, which sides do you think look parallel? Do you think it's these 2? Okay, are you okay with just writing right on top of your graph? I know there's tons of work in your notebook, don't worry about it. So going from H to K, pause. I always get nervous on graphs with geometry because when it comes to the CRT, last year, it was like 3 out of the 5 graphs were given count by 2s. And then lots of people missed it because they didn't count by 2s. They thought every graph was by 1s. So think like this one is by ones. So we just go up 1, 2, over 1, 2, 3, 4. So the slope of, what is that, HK is up 2 over 4. Simplify it, what is that? All right, 1/2. And then do the same for this one. Start at I, get to J. You don't count where you start, you count the movement. 1, 2, 3 spots up. 1, 2, 3, 4, 5, 6 spots over. So IJ, the slope of IJ is 3/6. Simplify, what is it? Okay, their slopes are the same. If their slopes are the same, what's the vocabulary for that there? Yes, they're parallel. Parallel slopes are the same. So right here we just proved that HK is parallel to IJ, therefore it's a trapezoid. One pair of opposite sides is parallel. If it was isosceles, which thankfully it's not, we would have to do distance formula for the other two and show that they both equal the same thing. Okay, what's next? Oh, here comes the mid-segment. So what happens on this is you add the two sides that are parallel, cut them in half, and it equals the mid-segment. I'll put numbers in there. I think when numbers are in there, it'll make more sense. Okay, you almost ready? What does that look like? Let's pretend that 80 was 10 and BC was 8. Can you find the mid-segment? All you have to do is this. Are you ready? Don't blink. What's 10 was 8? Cut in half. Done. That's it. That's what that formula is saying. Don't be intimidated by that formula. It was 11.5 and 10.5. Add them together, what is it? Cut it in half. So even if there's decimals, we survive those ones. So you agree with that? Okay, let's keep going. Oh, we just barely did one like this. Do it with your neighbor again. Start with your neighbor. Okay, help us out. What's angle A? Perfect, because it's isosceles, right? And then what's angle B? We'll sneak it in. And then what's angle C? Good enough. Here we go. Kites. Again, I already gave these away. Kites, you've got the back of the kite always forms a T. So don't forget, this is a 90-degree angle. Okay, and then the next there, exactly one pair. So maybe we need to circle that. Only one pair is congruent. Do you remember which pair though? Is it these two? Again, these two are going to be congruent. The chapter we had on triangles, you could prove that these two triangles are congruent by side angle side. If you drew in BD. Okay, then what's the relationship between B and D? Do you agree with Jane? Do you think B will always be bigger than D? In this picture? Auto, maybe, right? So to find these ones, you always know that one pair is congruent, and then just subtract from 360. Let's see if there's an example next. I can't remember. Perfect. Can you work with your neighbor and solve this one? Good luck. All right. Thank you for comparing. Hold your conversations. Does anybody mind defending themselves? How did you figure out S and U if this is what you're given? Ellie, thanks for raising your hand. What'd you do?
Well, S and U are.
Okay, Ellie, go ahead.
So S and U are congruent, and the whole thing equals 360 degrees. So 37 plus 73 equals whatever it equals.
What is it, guys? Okay.
And then you minus 110 from 360.
Okay, keep going.
Divide it in 2 and it equals 125.
Woo. So 125 for this one and this one?
Yep.
How many of you got the exact same thing? How many of you did the exact same thing Ellie did to solve it? Did you do the same thing? Okay, the next one, that bottom picture, we're not going to use it. It's pretty much the same question, different numbers. I'm going to show you a different example that comes up on your assignment, but it was never in your notes. So you might want to copy this down in that extra picture box. We're not going to do that picture. I have a question that looks like this. So why don't you take the time to sketch it real fast. Don't worry about accuracy. So today we learned that in a kite the diagonals are, yes, they're perpendicular. That's where you go to solve this one. So right here, add in your symbol. That's going to be 90 degrees right there. Since that's 90 degrees, let's just focus on this piece of the kite, this triangle. What kind of triangle is it? It's the right triangle. What theorem can you use because it's the right triangle? Pythagorean theorem. That's what we have to use. Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So take this, square it, take this, square it, and let's just call this side x. So 3 squared plus 10 squared will equal x squared. Thanks for staying with me. You've got this. What's 3 squared? Perfect. What's 10 squared? Oh man, this is going to come out sloppy. Add them together, we'll have 109 equals x squared. Do you remember how to get rid of a squared? Square root it at 109 equals x. Don't leave it like this. Let's get a decimal form. So those of you who have your calculators, type it in. Dizzy, do you have it?
Yeah.
What'd you get?
10.4.
Okay. So this side is going to be 10.4. And do you agree we don't really need to do Pythagorean theorem again? This one's also going to be 10.4. You okay with that reasoning? It's a kite. Be careful though. Is this one going to be 10.4?
No.
We got to do Pythagorean theorem one more time. Only for this side. So we've got a 90-degree angle right here. Let's think of this as our right triangle. I'm going to call this piece y. So leg squared, 3 squared plus 7 squared will equal y squared. 3 squared, 9. 7 times 7, 49. Oh no, another sloppy one. 9 plus 49, 58. Okay, without your calculators, can you estimate that? Y is going to be the square root of 58. Think of your perfect squares. What's a perfect square right below 58? Do you know? 49. What's the square root of 49? 7. So it's got to be 7 something. Because it's got to be between 7 and 8, right? Okay, type it in your calculators. I don't know what it is though. Does it go again? What'd you get? 6. Everyone want to back her up on that? You got the same thing? Okay. So that one right up here, we can say EW is 7.6. Same as ES.